Let's crush a Maffdoku. We got to put the numbers 1 through 9 in these black boxes. Purple clues are products. Brown clues are sums. So these three numbers have to multiply to 54. 54, 48, and 72 are all really divisible by a bunch of 2s and 3s, so these products don't seem that helpful. This 22 clue is huge, though. So these have to be pretty big numbers. Like 21 is 7 times 3, so the average of these three numbers has to be greater than 7. 13s are pretty small. Not super small, though. The average of that is just a little more than 4. 54 and 48 are a lot of 3s, though. There aren't that many numbers that are divisible by 3 here. It's just 3, 6, and 9. Is 48 not that many 3s? Okay, yeah, it's just 6 times 8. So 48 is only 1 3. 54 is 9 times 6. So there are 3 3s in 54, which means I need a 9 for sure. Yeah, I need a 9. And if I need a 9, then the other two numbers need to multiply to 6. So it's either 6 and 1 or 2 and 3. And I think that could go either way. So there's gonna be a 9 in this row, because if I did, what was my reasoning for that? Yeah, 6 times 3. Without a 9, I don't have enough 3s to get to 54. So if you do the prime factorization of 54, it's 3 cubed times 2. So 27 times 2, which is 3 cubed times 2. And if I don't use a 9, there's only 2 3s. Like a 3 obviously is a 3, and 6 is 2 times 3, and that's not enough 3s to get to 54. 9 has 2 3s. 9 is composed of 3 times 3. So that's how I'm thinking about those when I'm doing that. Okay, 48's probably pretty limited in its factors, especially if I couldn't have used a 9 anyway. But I think I probably need an 8 here, probably for the same reason. Yeah, Yeah, because 16 times 3 is 48. So I need 2 to the 4th here. 8 is 2 to the 3rd. Yeah, so for the same... 2 times 4 times 6 would work, wouldn't it? But that doesn't add up to 13, so it wouldn't work. So I do need an 8. I need an 8, and then I need two numbers that multiply... Yeah, it's 8 times 2 times 3. That's the only way this is going to work, because that adds up to 13. And I need an 8 in the row. Okay, so 2, 3, 8... 2, 3, 8. I would assume the 8 definitely has to go here. Yeah, if I subtract 3 from 22, I have 19, which doesn't add up to enough. And I think probably this is going to have to be 8, 9, which is going to put a 5 here. I'll check that again. Well, 5 doesn't, yeah, I think that's definitely going to happen. Okay, 2, 3, 8. My thought process there was, like, 5 can't go in either of these two rows, because 5 doesn't go into 54 and 5 doesn't go into 48. So 5 has to go into this row. And it seems like we're probably maximizing these two squares to add up to 22. I'm virtually positive this is going to be 9, 8, 5. I'll try to prove that without any doubt in a second. All right, 72. 72 is just 8 times 9 times 1, but I think we need the 9 and the 8 here, which is going to make this kind of hard. Okay, this is now 9, 6, 1, though. So the 6 must go here. The 1 must go here, I would think. 6, 1. Let me just prove to myself that this is 8, 9. So could this be a 6 maybe is the question? So if this was an 8, this definitely has to be an 8. I already proved that. Because if I subtract 3 from 22, these would have to add up to 19, and that's impossible. So 8, could this be a 6? 14, and then this would have to be an 8, so that's impossible. Because it's mathematically possible, but it's not Sudoku possible because this can't be an 8. So this is a 9. This is a 5 to add up to 22. I thought I had something else here. Maybe I don't. Okay. Well, this can't be an 8 anymore. This can't be an 8 anymore. This can't be a 9 anymore. This can't be a 9 anymore. These two numbers are 4 and 7. These three numbers have to add up to 13. So this can't be a 7 probably. Well, these two numbers have to add up to 6 if this was a 7, and they can't. So this has to be a 4. Which means that this is a 6 and a 3 to add up to 9. To make that work, this is a 6, this is a 3, this is a 1, this is a 7, this is a 2. That's going to be a Maffdoku, dude. There it is. Very cool. Thanks for watching. Catch you later.